Welcome to the Inclusive Practices in Mathematics in the Middle Years, grades 6 to 9 series for comprehension. We've been drawing upon resources from the ones that you see on screen and others to support our learning. You'll see some practices and instructional strategies and ideas come forth in our learning and slides that we see later on. Let's start with understanding what UDL is and how it's informing mathematics practice. If we were to do a sentence explosion and look at the specific words that we see on the screen, universal really refers to the variability that we see in students, their inter and intrapersonal variability. This refers to all of their needs, which can encompass learning, social, emotional, physical needs. We want to think about students as individuals and embrace their variability as we start to plan for inclusion, and we provide access for all learners. That is entailed in the design process, where we set learning goals that are based on our curriculum, but then also include things like language and possibly particular aspects of the UDL framework that will be a focus. Really, what's instrumental here in the goals of UDL is that we support students in becoming independent learners who can access their own learning needs, monitor their progress, regulate and sustain their interest and effort and persistence during a learning task. We do that by providing multiple means of engagement, keeping students interested, offering various forms of instruction, also providing choice and representation of materials and texts that we're using. In addition to that, providing opportunities and flexibility with what students choose to represent their thinking and understanding. Today, we're going to talk about what is the relationship between comprehension and mathematics. We will dive into how we might support growth in comprehension in mathematics and how we might support students in expressing and representing comprehension in a variety of ways. Often when we think about comprehension, we connect it with what we know about comprehension and literacy, and that is the ability to understand, critically analyze, and create a variety of forms of communication. And this really entails that students have access to text, that they actually engage with text, and then they show their understanding of various forms of text. So they make connections, they process information, and then they transform their understanding and thinking. There are links to all of those in how we sort of scaffold learning in mathematics. This is a document that can be found in our SD38 Pillars of Literacy, where we want to pay particular attention to how we would plan to support students with growing their comprehension skills. We want to always provide opportunity for students to engage in activities with strategies in mind so that they can engage in deep learning rather than superficial and passive learning. So when we think about comprehension in mathematics, there's a relationship there where comprehension in mathematics is essential for students to build new knowledge from their experiences and prior understanding. It involves understanding concepts, procedures, and relationships between them for learners to engage with complex mathematical ideas and tasks, such as making connections between mathematical concepts and real-life applications, reasoning, problem solving, using various representations to understand and communicate thinking and mathematical ideas, and even offering justifications for solution. These are just to name a few. So, as we design experiences for students to practice comprehension skills in mathematics, we always want to be cognizant of who our learners are and what their needs may be. And as Shelley Moore describes, needs are specific challenges or barriers to learning that students face while they're learning. These might be like learning social, emotional, or physical considerations. When we know what students' specific needs are or their barriers to learning are, we can design the specific supports or tools that they need to be able to access the learning and to engage in the learning. And those tools are things like graphic organizers, glossary with definitions. They could be use of manipulatives during time, independent time to process information. But we also want to scaffold learning by introducing strategies that students can draw upon. Those are the actions that increase their independence when they're working on specific tasks. So, as they encounter something that's challenging, they have a specific strategy to draw upon. We are going to look at how we might provide opportunity for students to practice comprehension strategies during our lessons. We'll take a look at the three-part lesson structure, although we do design multiple lesson styles when we're engaging in mathematics. This three-part lesson structure starts with us looking at before, where we would activate prior knowledge and language and explore ideas. Then during, where we would investigate a concept and practice competencies. And then after, where we consolidate and reflect on learning. So if we explore learning strategies to support growth and comprehension in the very beginning of a lesson, we can look at creating an inclusive climate for learning. This is sort of setting up the classroom to get engaged in the learning, where we identify and teach math vocabulary and language of focus. We can use instructional routines or math provocations to access that prior knowledge or to get students building upon thinking that we've explored in previous sessions together. We can also think about creating or building on students' funds of knowledge and their particular interests. So we want to think about what are some situational contexts if we're looking at a specific problem that might be of interest to students. Something that might be relevant and timely so that they can see themselves in the problem, then they can hold on to the meaning because they're making connections to that particular context. And we can also identify and teach strategies for students to comprehend instructions. So before we do all of that, we kind of want to consider what students' needs are, and then think about what supports and strategies they might need to navigate their learning independently, given their needs. So when we're considering learning needs, that might be that we need to provide supports around comprehension, providing some things around background knowledge, or some ways of understanding the context to a problem. If a barrier is language, we want to think about the vocabulary, tier 2 and tier 3 words that we might provide specific instruction around. We want to think about if there are social needs that student might have, peer-to-peer interactions or constructive group work dynamics that we need to consider as we're designing those learning experiences for students. We also want to consider their emotional needs, like math anxiety is very prevalent in our schools and in our classrooms. And so when we set up climates for learning that are inclusive, that give them strategies that they can use independently to engage in math learning, we can acknowledge that barrier and work towards students feeling more confident. If students have physical barriers to learning, we can also think about how we might provide access for those students. If they've got a visual impairment, what sorts of tools might be helpful? So an example of that is if we were to do a number talk routine at the very beginning of a lesson, usually to access that prior knowledge, to bring out some common language, to talk about particular strategies. We want to support students in being able to do that based on their needs. So some students might benefit from having a glossary of terms, or I might put an anchor chart or up on the whiteboard particular terms that I want students to practice using as we engage in this instructional strategy. I might also provide some sentence frames like I think, because, this strategy is called, I agree with. And I might even think about specific materials that might be supportive to students during these activities. Like, would they benefit from having an individual whiteboard? Do they need a timer so that they know how long to expect for this activity? Would it be helpful if they had some concrete materials at hand? So during the lesson, we want to think about how we also might support comprehension during our lessons. So some examples of comprehension skills practiced at this stage in learning might be that they're making connections, they're predicting, they're making assumptions, they're starting to question, make inferences, starting to identify particular things, synthesize information, visualize, monitor understanding. We're going to try to identify one of those particular skills or two that learners would benefit from practicing while engaging in this part of the learning. And then as we have that in mind, we want to think about a strategy that might be helpful for learners as they are diving into that learning, and then start by modeling how to use that strategy. So for example, if I want to support students with making connections in math, a tool that I might provide students is one that we can see on the screen, making math to self connections, math to world connections, math to math connections. In addition to that, I might also be sharing criteria for proficiency, or what my expectations are in terms of their sharing. And I would try to go through a process of modeling with them. If I have a context in which this is going to be important, we would go through each one of these, or one only, to see how it's going to help them deepen their understanding of the topic or the idea or the procedure at hand. The really important thing with making connections is not just to make the connection, but to identify how that connection is helping them understand the context or the new learning that is happening. Another thing that we can do during lessons is to try different instructional routines, or sorry, different instructional strategies that require students to practice multiple comprehension skills. One of those could be something like a math circle. This is very parallel to what we know in literacy as a literacy circle, where students work in groups. In this case, they have a very rich math task and work in small groups of 3 or 4. And each student is assigned a particular role. So the ones that I've identified on the screen are come from this resource that you see on the side. You can name them to be suitable to your environment and context. But the idea is that there are, each student is provided a specific role. There's a graphic organizer that supports their output during that time. Everyone has an opportunity to practice a particular role, dependent on the investigation or the task at hand. So you might not need all 7 roles at one time. Choose or select the ones that make most sense to that particular investigation. And then provide multiple opportunities for students to engage in this instructional strategy or group problem solving using this format so that they can try out different roles. And the more they try the different roles, the more they are building their comprehension in different ways while investigating and trying, problem solving processes like we see on the left. After we learn, we continue wanting to try how to deepen understanding of topics. And so we want to think about what strategies might support growth and comprehension even then. Math journals are a really good way to start that process. They can be used to help students organize and clarify thinking processes for math that is being explored. They can also make connections across math ideas, see and use a variety of strategies, monitor and reflect on progress. And so the useful thing to do is to always provide students with prompts, and the prompts you provide are specific to the comprehension that you are targeting at that time. So an example of a particular prompt are reflective prompts. It could be a prompt that looks at students' understanding of topics and concepts. It could be that we want students to connect to real life applications. Here's some examples of student reflections. So if a student was doing a reflection, they say, today we learned about slope. The most confusing part was figuring out the difference in the third quadrant because there are a lot of negatives. I think I need to do more practice with integers to help me with this, right? If I was exploring a concept, it provides students with prompt, and this is an example of a particular response that a student provide. I figured out I can use decimals, fractions, and relations to represent the same number, for example. So the student could be showing a specific value and how it can be represented in many ways. An example of a connection to real life is I saw a graph in the newspaper showing the rise in gas prices over time. I'm wondering how I can use what we learned about linear equations to understand the information more. So that's an invitation for an inquiry, making a connection to a real world experience, and then having them practice the concept at hand, which enables them to hold on to meaning. So when using math journals, encourage learners to explain their thinking process, use prompts to guide reflection and critical thinking, encourage them to use diagrams, graphs, and other visual aids to support their explanations, and create a safe space for learners to ask questions and express their uncertainties about math concepts. Another way that students can show that they're comprehending math is to look at how we would be communicating and representing thinking. So there's lots of forms of mathematical communication. We can communicate orally, which has to do with our ability to, or speaking and listening. We can communicate in writing, which has to do with reading and writing. We can look at symbolic communication, which is graphical or pictorial. And then we can show our, communicate our understanding through using concrete materials, like physically. I mean, no one form is more valuable than the other. So the purpose of having students be able to communicate is for them to organize and consolidate their mathematical thinking, for them to communicate their thinking clearly to others, for them to be able to analyze and evaluate mathematical thinking and strategies, and to use language of mathematics to express their ideas. When we think about communication and representation in mathematics and relate it to our curriculum, in mathematics literature, the term CRA is typically used to discuss representation, and it stands for concrete, representational, and abstract forms. But in BC, we use the terms concrete, pictorial, and symbolic. So we want to provide students with opportunities to show their thinking during the learning process and after in these particular forms. The amount of communication that occurs in a math classroom is significantly affected by the nature of teacher questioning. That was stated by Marion Small. And one way that we can do that is by thinking about the specific skills that we want students to be able to practice at different points in our lesson, and design questions that can promote that type of thinking and learning. These are particular discussion prompts that teachers can use to target specific types of thinking. On the left, you can see how we can help students learn to reason mathematically, how we can help them evaluate their own processes, and how we can help them connect mathematics to ideas and other forms of application. We can also try to encourage students to reason, conjecture, justify, and defend their thinking, and question others' processes and solutions by providing rich, open tasks that foster oral communication in small groups. It's very important that students have opportunities to learn together, talk through their learning together, and try different approaches to questions and learn from one another. So some sources for particular rich open tasks are shown on the left, but some helpful tools to provide students when they're having discussions and going through solution-based problems together are graphic organizer. There's some mathematical discussion thinking prompts there to get students started. For example, what strategy could be helpful? What could we try? Do you agree or disagree? These are things that we can have on hand on tabletops, either in tent form or just on paper, for students to be able to refer to as they are engaging in conversations with peers. In addition, when we're presenting students with texts that are rich in words, we want to provide the tools necessary for them to be able to interpret the instructions and the context. And what might be helpful are the glossary of terms, or particular strategies to use when they come to words that might be challenging. Some other types of written communication and representation that we can use to encourage students to demonstrate their thinking and comprehension, particularly in written form, is to provide opportunities for learners to inform, persuade, describe, and evaluate. So we can do this in various ways. You can offer opportunities for students to do some personal writing, descriptive writing, process writing, creations of word problems. You can create opportunities for students to do some creative writing, explanatory writing, critiquing. And you've got some examples on the screen to see what that might look like in different contexts. What we want to pay attention to, though, is always providing opportunities for students to learn in different ways and to choose the ways that are most significant to them. But initially, they need to be shown how to use materials to help them develop understanding. So this is a quote by Dr. Francis Fennell. And it reads, "The process of representation includes models to organize, record, and communicate mathematical ideas, as well as selecting, applying, and translating these models to solve problems and interpret mathematics. The models can be used to show math through the use of manipulative materials, diagrams, graphical displays, and symbolic representations." So one way that we can invite students to do this is to use tools like graphic organizers for them to show relationships between the various ways that we can represent mathematical understandings. But then to take it to that next level of critical thinking, we're inviting them to share what they understand to be the relationship between those forms of representation and how it's helping them understand a particular process. So, for example, how are base 10 blocks helping you understand how to multiply decimals? There are a lot of resources available on RichNet. We are populating the inclusive practices tile, um, every so often with graphic organizers, samples, resources. There'll be links to other videos that we've done to support inclusive practices on our YouTube channel, and more. As you start to think about how to um, build in some comprehension practice in your classroom, think about how you can, in your next unit of study or lesson sequence, create opportunities for students to grow their comprehension skills in mathematics. Thank you.